Today, we're discussing finding all subsequences given a sequence. And by sequence, this could be a list, a string, an array, or anything that could be iterated. In this particular case, our sequence is an array of letters. Here we have A, B, C, D, and E. And contiguous, what is meant by this? Contiguous means that we can have a subsequence in which we're not skipping one of the original inputs. So for example, if our subsequence consisted of A, B, and C, that's okay, that's contiguous. On the other hand, if our subsequence consists of A, B, and D, because we're skipping that C, then that subsequence would not be contiguous. So now that we know what our sequence is, and now that we know what the definition of contiguous is, let's look at a method that we can apply to find all the subsequences. So this is a method. You have a left wall, and then you have a right wall. And these walls are moving through the sequence, and as that's happening, you're yielding what's between these walls to get your subsequence. So this method consists of really 3 steps. The first step is to do an outer loop through each index to find the left wall. So steps, and step 1 is to outer loop through each element or each index in your array, and this will define the left wall. Now do notice that I'm abbreviating left wall as LW. The next step is for each left wall index. We then want to find all the indices between the left wall and the end of our array. And this will give us all of the indices that we need for the right wall. So step 2, inner loop from the left wall all the way to the end of our array. And this will give us the indices that we need for the right wall. Now do notice that just like for the left wall, I'm abbreviating the right wall as RW. So once you have your left wall defined, and once you have your right wall defined, to find the subsequence, you simply return all of the elements between and including the left wall and the right wall. And that's step 3. So we're going to yield the subsequence. We call the subsequence SS. Of all of the items at the left wall and between it and including the right wall. So do note, I'm using interval notation, and what this means is that we're including the element which is at the left wall, everything in between, and we're including the element that's at the right wall and everything in between. So now that we have these 3 steps defined, we can apply them to find out all of the subsequences here that we have in our problem. All right, so before we get started, I'm going to label the indices on our input. Because we're doing this by hand, it's going to make it easier for us to see what we're doing. So here the index is 0, the index is 1, 2, 3, and 4. Perfect, so now we have the indices. All right, so let's look at the very first step. The first step says that we want to loop through each index, and that will represent the left wall. So the first index is here, so the left wall is here, the left wall is 0. And then step 2 says for each one of those left walls would fall into this inner loop, and then loop from where the left wall is all the way to the very end. And that's what the right wall will be. So the right wall will start off being equivalent to the left wall. So it starts off right here. And then step 3, which is inside of this inner loop, says that we want to then yield the subsequence defined by that interval. So let me show you over here. So we have A, which is our input, and using interval notation, we have the left wall, which is 0 for the index, and then we have the right wall, which is also 0 for the index. And then we want to yield the result that is defined by that particular interval. So keep in mind that this represents including. In this situation, they're both 0. So we're looking at what element is there. and we end up with A. So A is the very first subsequence that we have. And I'm going to write my answers here so you guys can see it. So here we have the very first subsequence. Perfect. So now that we did step 3, we're going to jump back into here and increment the right wall by 1. When we do, the right wall is going to go from 0 to 1. Step 3 says we then want to yield the result that is between 0 and 1 within our input and including. So when we do, the result will be A and B. And we can write that here. Perfect. So again, we're going to continue to increment the right wall. When we do, that will be the interval which these 3 items lie on. So we'll have A, B, and C. Put that as your third subsequence here. And again, we're going to continue to increment the right wall. And we have that. And then this defines the interval of A, B, C, and D. Perfect. And then we're going to continue to increment the right wall one more. And this is what we have. So now we have A, B, C, D, and E as our subsequence. Perfect. So now that we have this fully defined, do notice that the right wall, there's no other index to go. And because of that, we can then exit that inner loop and then return to the outer loop. So let's do that. When we go back up here now, keep in mind that the left wall was 0, and because we're incrementing for each index, the left wall will then become 1. What I'm going to do here is I'm going to erase all this to make more space. Erase this and that. We don't need that anymore. And erase that. All right, perfect. So now, again, we're here. And the left wall is 1. The right wall we haven't defined yet, but we're going to get to it. So we go to step 2. Step 2 says you're going to start off by defining your right wall by whatever you have for your left wall. So that would be right here. And then step 3 says you're going to yield the result that is defined by the interval. When you do that, let me erase this real fast. When you do that, you will end up with the letter B. So B is going to be the subsequence defined by that. And that's what we have. So we return to this, and then we're going to increment the right wall one more time. And this is what we have. Step 3 says you want to yield or return the subarray or subsequence that's defined by that. Here you have the subsequence of B and C. And then return to your inner loop. You'll increment the right wall one more time. You have that. Step 3 says you then want to yield the subsequence that is defined by that interval. When you do, you'll get B, C, and D. B, C, and D. Again, return to your inner loop. Increment the right wall one more time. And step 3, you're going to yield the subsequence that is defined by that interval, which is between 1 and 4. When you do, you'll get B, C, D, and E. All right, perfect. So now that we have this for the right wall has gone to the very end, and therefore it's going to exit that inner loop and return to the outer loop. And what I'm going to do is I'm going to erase all this to make more space. Erase that, erase this. All right, so right now the left wall is 1. When we increment the left wall, it will become 2. And once we have that, we're going to define the right wall. So the right wall will be defined at first as the same thing as the left wall, which is also 2. Step 3 is to yield the subsequence right here. When we do that, we're going to get C. Next, we go back to step 2 and we're going to increment the right wall. And then we're going to yield the subsequence, which is defined by that, and that is going to give us C, D. The next, we're going to go to 2 again, and that will bring us to the E. Therefore, we have C, D, and E. Perfect. Once we've completed that, we will then return to the outer loop, and then we're going to increment the left wall. So the left wall is here. After incrementing, it will end up right here. Step 2 says you're going to define the right wall where the left wall is, which is right here. Step 3, you're going to yield that result. In that case, we'll end up with D. Put that as one of your results. So this is our next subsequence. After that, we're going to go back to step 2 and we're going to increment the right wall. When we do that, we will get D and E. And then after that, your right wall is done. Therefore, you will return back to the outer loop. Erase that and erase this. So right now, the left wall is here. After incrementing, we'll have the left wall be right here, which is the very last index. Step 2 says you're going to write the right wall where the left wall is. Step 3, you're going to yield the result of that. When you do, that will give you E. So now the right wall has reached the end of that array, and then also the left wall has reached the end of that array, and then therefore you're done. So once you've applied all these 3 steps, you will end up with these subsequences here.